Hello there. Yesterday we talked about rates of change, and today we're going to continue that. This is 2.4 in our books, 2.4. And but this time we're going to look at it in the general case and figure out what a derivative is and the slope of the tangent line and all that stuff in the general case. All right, so I'm going to make a graph, and the best I can, I'm going to make it go just my first attempt at it. Not too shabby, not too bad right there. Okay, so just some kind of graph that tails off like that. And then I'm going to pick 2 points. One is going to be right about in there that I'm going to call point little a. Okay, because we're going to pick things that's going to represent any number we put in there. Okay, for this function, this pink function here. And then what I'm going to do is I'm going to pick another point, which I'll make green right there. And we'll call this point A, but we're going to add a distance to it. And the way that all calculus books I've ever seen does this is they add a distance called h. Okay? So this distance right here from point number 1 to point number 2 is h in length. Okay? So this is a plus h. Does that make sense? So if this was 2 and h was 3, this would be 0.5 out here. Okay? So a and a plus h. Now these are the, we will come up here and put a point right there representing that blue. In fact, let me make that blue so it all looks good. And then I'll make this one green. There we go. And it's going to correspond to certain y values. It'll come over here and over here. Okay? If this is an a value, and this is some function. Now, I didn't define what that function was. It's some kind of, looks like some kind of parabola or something. But whatever that function is, and it really doesn't matter here, the way that you would tell what the y value is when you have the x value is to evaluate that function. You would plug x in, and it would spit out the y value. And the way we do that in calculus, or in algebra even, is this would be f of a. Okay? So that's f of a. That's the y value when the value of a is evaluated. And up here, this would be f of this point, which is a plus h. A plus h. Okay? Now, this does have to do with slope of this secant line again, but let's look at the difference of the two things here. This time we know that the difference between this blue point little a and this green point a plus h is h, because if I actually subtracted the two, a plus h minus a, I would get h. Okay, so that's the difference. That's like taking x2 and x1 in the past. I'm going to delete that, but you can see it's like x2 minus x1, like we did yesterday. So let me get rid of that so it doesn't goof this up. This distance, let me find some kind of strange color. This distance here is the difference between these two. So instead of y2 minus y1, it's going to be f of a plus h minus f of a. So it's this minus that. So we call that f of a plus h minus f of a. Now hopefully you can see that. That's, in fact, let me just make that a little bit neater. Write that a little bit bigger. It's f of a plus h minus f of a. Again, that's like saying y2 minus y1, but we're doing it in the general case. Okay? Now, if we're taking the slope, if we're figuring out what the slope is, that's, of course, the change in y over the change in x. And normally, that would be x2 minus x1 divided by or I'm sorry, y2 minus y1 divided by x2 minus x1, just like yesterday. But in this case, it's going to be the difference in y values, which is this minus that, and that's this right here. So that's going to be on the top, f of a plus h minus f of a. One thing minus the other. And on the bottom, it's going to be this value, this x2 minus x1. So it's going to be a plus h, I'll do this one more time, minus a. And if we simplify the bottom, we're just going to get, again on the top, f of a plus h minus f of a over, and this of course simplifies to just h. Well, this right here is a very powerful formula that allows you to do a lot of stuff, especially when we shrink the distance like I started talking about yesterday. As I pull this distance closer and closer, in fact, when I approach zero distance for h, and I take what's called a limit as h approaches 0 of this function over h. This is how you find the slope of a tangent line. Now remember, a slope of the tangent line. This is the slope formula in disguise right here. It's also known as the instantaneous rate of change. And I'll be honest with you, I don't think any of this stuff beyond this is going to make any sense until you understand this picture. So it would be wise of you, if you're serious about learning this, to practice drawing this picture and put a here, put a plus h, and see if you can get all this to work out to equal this box right here, because that formula, we'll be using that all the way through chapter 3 as this is called taking the derivative of something, and that's the general rate of change problem. See you later.